Hello YouTube, this is my RO-DI system. RO meaning reverse osmosis, DI meaning deionized water. To make deionized water, which is preferred in the reef keeping hobby, you first must RO the water, reverse osmosis it, to clean out 95 to 99% of your city's contaminants. The last bit of the contaminants then get cleaned out by the DI membrane. The DI membrane is that top plastic tube that's horizontal. It has nuclear rated deionizing resin. I'm not quite sure how it works, but if you take dirty water, even if it didn't go through the RO membrane and run it through that, it would come out pure at the end of it. But it gets clogged up fast if you run dirty water through it. That's why you have to run primarily cleaned out water from the RO membrane, reverse osmosis, before you run it through the deionizing unit. Most home units work off of that principle. The big industrial water purification plants, they do it backwards. They run it through deionizing and then they run it through the RO. I don't understand why they do that, but they do. But the typical home unit is first RO, then DI. The benefit to that is the RO water you can siphon off and drink it. And that's what I'm doing here. Right now I'm making 3 gallons per hour. This is a 75 gallon per day RO unit. The wastewater comes out this tube, which goes down through my hot water tank emergency drain line. The purified water comes out that through this polishing taste carbon filter, which gets changed about once a month. From there, it leads to my collection vessel, and I have a cooler stand in my kitchen. This water was coming in from the city at 600 parts per million contaminant. After the sediment filter, carbon block 1, carbon block 2, it was down to 241 parts per million. After the RO membrane, it was down to 3 parts per million. So this is 3 parts per million water. For an experiment, you can go to the 7-Eleven and buy a bottle of Dasani or Fiji water or any of the brand names and test them, and they usually will be more than 3 parts per million contaminant. Now, when we talk about contaminants, we don't know what that is. It could be arsenic, it could be copper, it could be calcium, it could just be sand particles, but you don't really know what it is. Although I assure you, if you buy commercially bottled water, it wouldn't have, something bad. It wouldn't have arsenic in it or anything. But your home unit, you really can't tell what those parts per million are. So, but it's certainly a lot better than what we started with at over 600. Now, I keep an emergency supply of water in my house. I always have, 400 or 500 gallons of drinking water because I'm a prepper type mentality person. But primarily this unit was purchased for my fish tank hobby. So after I have my drinking water made, I pull the hose off of this filter and I insert it into the deionizing unit, and then it continues on its path into my 95 gallon city trash can, which is brand new. It didn't have any trash in it. When it leaves the deionizing unit, it's always 0. That deionizing unit does a great job pulling out the last parts that the RO didn't. Now, when my RO membrane goes bad, it starts producing 10 parts per million TDS. It starts producing 15, 20, and it does it over a very rapid period of time. And once it hits about 30 parts per million, that's when I replace it. Now, it lasts about 3 years if you take care of it. But the deionizing unit, no matter how high I've ever seen my RO unit, it removes whatever's left. It'll take 40 parts per million RO water down to 0 parts per million deionized water. So it does a great job. But the dirtier the RO water is, the faster you have to replace your deionizing media. Deionizing media is just it's a bunch of beads that it goes into a chamber and water gets run through it. Now, I will advise you to hang your deionizing chamber vertically. The reason this one is horizontal is because I got it for free. I got it from my local fish store. It was in a box. They didn't want it. I grabbed it, and it came with the mount to mount on top of the RO membrane. So that's why mine's vertical. So what I do is I rotate it, you know, a quarter a turn every time I'm making water, so it the water runs through a fresh area. That deionizing chamber has made 1,000 gallons of water, and it's still making 0. So, and it's hard to tell too. Sometimes I'll make 300 or 400 gallons and it'll need replaced, and other times I'll make 2,000 and it's hard to tell. Now I've noticed if I make water on Sundays in my locality, my water that's coming in my house is only 200 parts per million to begin with. What comes out at the end of the sediment, the carbons on this side right here, where this TDS meter is reading, is as little as 50. And then the RO membrane is like, after that, it comes out at like 1 parts per million. But if I make water during the week, the water's dirtier. I have no idea why. It's just an observation. So I try to make my water on Sundays because the filter just works more efficiently for some reason. The reason I'm drinking the water off of the RO membrane versus the DI is there's some discussion on the internet that you shouldn't drink deionized water. The conversation revolves around, yes, it's absolutely pure medical grade water, but items that are totally free of any items in them, when you drink it, they pull water from your bloodstream or your organs into them, and then you urinate out the particles, basically meaning it actually dehydrates you. I don't know if those arguments have any validity or not, but because my RO filter makes such clean water, I don't push the issue. I just drink the RO water. I got this filter for free. I got it off Craigslist. It was on the Craigslist for $50. The guy traded me a canister filter that I had that I wasn't using, so I got it for free. But you can pick them up used all day long for $50. Now, when you buy one used, you want to replace the filters, and this filter is $35. The RO, the main filter, is $35 to $40 for a dowel filter, which are the best. They're U.S. made, and I got that one from Bulk Reef Supply. And I wasn't sure of the size, so I took a picture of the inside of it, and they sent me the right one. I found out later that like 99% of all home RO units use the same size RO filter, so that's a no-brainer on that one. The first one is a sediment filter, the second one is a 2-micron carbon block, and the third one is a 1-micron carbon block. The sediment filter on my locality should be changed once every 3 months. I plan on hanging one of these chambers right there and putting a sediment block in there and then putting another one in here. So this one would only need changed once a year, and that one changed every 3 months. That's my plan for, because my locality uses a lot of silica in their water on purpose to clean out the pipes, so they don't have to do any maintenance. But if you have city water, if you fill a 55-gallon trash can up with water and let it sit for a day, and then come back and take a flashlight and look at the bottom, you'll see about 1/4 of an inch of sand at the bottom of your water. And normally that's suspended, and you drink it and you don't even notice it, but it is in the water. My carbon blocks, they get replaced about once every 6 months. And how I determine when I need to replace it is when I'm making drinking water, my drinking water jugs that fit on top of my cooler, they're 3 gallons apiece. When they stop making 3 gallons per hour, or 75 gallons per day, that tells me my sediment filter is starting to get clogged and my carbon blocks are starting to get clogged. So the first thing I do is I change the sediment, and then if the water pressure is still down, then my carbon blocks need to be changed. Now, if you throw a few extra bucks at the system, you can buy a pressure gauge and put it in line on the city side and then one on the end of the carbon block, and you can tell if the pressure starts to fall at the end of the carbon block, then your sediment filters need to be changed. I plan on doing that down the road, but I haven't done that yet. Now this is a TDS meter, that's inline TDS meter, and I have this hooked up after the carbon block. So today I'm making 266 parts per million water after the sediment and the two carbons. The other side of it is on the sensor is on the outside of the RO membrane. So I'm making 3 parts per million when I started with over 600 parts today. And that's my drinking water. Now the reason I'm making this video today is because my carbon blocks need to be changed, and I changed the sediment filter already this week, and I'm still not making 3 gallons per hour, and the blocks are about 6 months old. And I have a video on how to change these chambers out on my carbon filters for my fish tank. You can watch that to see it works the same way. The wrench goes on, and there's directions for close and open. You put them on there, and then you just turn. And these are pretty much hand tight, but I still have a wrench in case they stick. Now I have a bucket here, which you heard fall to the ground a minute ago, because you ultimately lose some water in this process. And to minimize what's on my floor, I have a bucket ready. You spin this off, and then you just dump the old carbon block into the bucket. And this is the 1 micron. It goes last. And if I can do this one-handed, you can see how easy it is. If I turn it the right direction. Okay, now I'll do the 2 micron carbon block. Now, one of these carbon blocks is made from coconut shells. It's hard to believe, but the natural carbon in coconut shells is preferred for this, and the other one is just a high purity compressed activated carbon product. And I can't remember which one is the coconut and which one's the chemical, but and that's it. Now, because I already changed the sediment out, I can't show you that, but the sediment filter is just basically a yarn filter. They cost $1 at my local plumbing store. They do make some fancier ones you can buy for $3 or $4, but you know, I rather change it out more frequently than and know there's a fresh one in there versus having a higher quality one that you might last a month longer. That's just me. The RO membrane, if you take care of it, will last 3 years, or something like 8,000 gallons of water. This one, because I bought a dowel, I think I probably run 8,000 gallons through it already, and it's still making, you know, 3 TDS water. Now, how you take care of it is by flushing the outer membrane. Okay, how an RO membrane works is the water comes in the center and it comes out the membrane and gets collected through this side. The water that runs across the outside of the membrane comes out here as wastewater and goes down the drain. How you force the water through the membrane is having back pressure on it, and that's what this thing is for. This is a flow restrictor. Now, you can, instead of using a flow restrictor, just use a ball valve and start to restrict it back. by using a ball valve. But these are like $4, and why bother with the headache when you just call a filter company, the filter guys or Bulk Reef Supply, and tell them that your RO membrane is a 75 gallon per day or 50 gallon per day or 150 gallon per day, and they'll send you the right flow restrictor, and you just put it in line, and it causes back pressure in the filter, which causes the water to come out the membrane. But the opposite side of the membrane that's making the clean water gets clogged up with all the sand and silica that made it past these blocks. So you have to wash it off. Well, how you wash it off is don't restrict it. Remove the flow restrictor, turn the water on. The water will fly over the top of the membrane and wash off all of the buildup crud. Now, I do it very basically just by removing the flow restrictor. You can put a hose that goes around the flow restrictor with a ball valve, and all you do is open it, and the water just goes path of least resistance and bypasses the flow restrictor, and that's how you can wash off your RO membrane. But you don't need to do that. You just pull it out of line and then put that in a bucket and just or down the drain, and it just washes it off. And if you do that, every couple hundred gallons, the membrane will last a very, very long time, and that's the case with this one. Let's take a look how I have it hooked up. All right, I'm going to turn the water back on. Okay. Now the water right now, again, is going through the sediment filter, through the carbon block, through another carbon block, through the RO membrane. The product water's coming out here and going into my drinking container. Now what's coming to here is 60 psi right to here. And how I know that is I have a pressure gauge, which I'll show you down here. There's not a lot of light here, so I hope you can see. That's what the pressure gauge looks like. You can buy these at Home Depot and hook it on to your spigot, and you can tell what your house pressure is. Now this house, the city provides it with about 100 psi of water, which is too much for the membrane. So you have to have two ball valves. One to turn on and off from the city. That's how I turn off the RO when I'm not using it. That's all the way on. Second ball valve sets the pressure. So you have to put that pressure gauge on the line, turn the valve on, and then crank down the pressure. Then the line connects onto this press fitting here, runs up to the RO membrane, and here's where my wastewater is. There it is. My unit is an inefficient producer because it's an older model. It wastes 3 gallons of wastewater for every gallon of drinking water that it makes. Now, there's a way to minimize waste, and what you do is you buy a second RO membrane, and the wastewater tube you run to the front of the second tube, and what that does is makes 2 gallons of water for like every 4 gallons of waste. So it's a more efficient way to do it. And I actually have the second housing, and the next time I order another RO membrane, instead of ordering just one, I'm going to order 2, and it'll snap on up here. And then my deionizing unit will get hung vertically here on the wall. Vertically is more efficient because the water goes over the media more evenly. And that's how I'll double my output, which means my unit will make 6 gallons per hour instead of 3. What else can I say? I think that's about it. I hope you enjoyed my video. Hope it helps you understand how these systems work. You can add all sorts of fancy accessories to them to make them more user-friendly, but for a beginner, it complicates it. You can have these hoses directly hooked up to your trash can with an auto turn off system to where you don't actually come out here and turn the water off. That's nice because I have let the thing run too long and it overflowed my garbage can. Not a big deal to me because my trash can, there's a drain in the garage floor and the water naturally goes to it, but it did waste water. I actually do have the auto shut off system, but I just haven't hooked it up yet. Let's talk about, should you buy a used one or look for a used one? There is a place I refer to a lot on my videos called Bulk Reef Supply. If you've spent any time as a reef keeper, you know about Bulk Reef Supply. The RO membrane that they sell only costs $200, and it comes with the pressure gauges I talked about. It comes with the auto turn off system. Comes with a Tds meter. Comes with everything that you need. And if you buy it new from them, compared to other manufacturers, you get the filters for free. And I think it's the best value on the market. The other place I use is the Filter Guys. Their membranes cost a little bit more, but if you piecemeal out the stuff, you can save a few bucks by going with them. Like if you were going to add a second sediment filter on the front, the Filter Guys would probably be cheaper than Bulk Reef Supply. But if you're going to buy the unit all at one time, Bulk Reef Supply is the cheapest I've found. Have a good day.